Hello, this is Iris, and today I'll be presenting my Data for Good project on missing children in California. So a little bit of background information on this topic. Typically, when a child goes missing in California, a parent or guardian will file a missing persons report to law enforcement. So there's different types of missing children's reports, and this includes runaway, lost, catastrophe, stranger abduction, parental and familial abduction, suspicious circumstances, and unknown circumstances. And typically, when these cases are resolved, um, there are several different statuses, which include returned, located, deceased, arrested, emancipated, voluntary missing, and withdrawn/other/unknown. So for the first research question I decided to investigate, it was, is the mean number of missing persons reports greater for female children than for male children in the state of California? And I decided to investigate using a two-sample t-test for difference in population means. So firstly, for my data collection, I collected it from the State of California Department of Justice Office of the Attorney General database. And as you can see here, the year is given, and the frequency of missing children's cases for children in California are given for both males and females, and the data ranges from 1996 to 2023. And as you can see in this comparative bar chart, we can see the frequencies side by side. So to begin our two-sample t-test, I started by defining my populations. So mu1 is equal to the true mean of yearly missing persons reports from female children in California between 1996 and 2023. And mu2 is equal to the true mean of yearly missing persons reports for male children in California between 1996 and 2023. For my hypotheses, I define the null hypothesis as mu1 minus mu2 equals 0, and the alternate hypothesis as mu1 minus mu2 is greater than 0. And I use a significance level of 0.05. For the assumptions, well, firstly, this data is representative sample of missing children's reports for Californian children. Secondly, less than 10% of Californian children go missing, so we're able to assume independence. However, for the last one, the data I used ranges from 1996 to 2023, which is only 28 years, which is less than 30, so we cannot assume normality. So we have to approach this data analysis with caution. So to begin the test, as you can see here, this is the formula for the two-sample t-test. And I basically just plugged in all my data into my calculator, and I got the observed means and the standard deviations of both samples. And as you can see here, I plugged in all the values I got into the formula. So next, from before, I got t equals approximately negative 4.52, and I got a p-value of approximately 0 and a degrees freedom of approximately 42.389. For our conclusion, because p-value is equal to approximately 0, which is less than alpha of 0.05, we reject the null hypothesis. We have sufficient evidence to show that the mean of yearly missing persons reports for female children in California between 1996 to 2023 exceeds that of males. However, because n is equal to 28, which is less than 30, we have to treat these results with caution. So the implications of these results, our results imply that female children in California may be in a more vulnerable position to go missing. Thus, further investigation by lawmakers and law enforcement is needed to identify the underlying factors contributing to this disparity and to develop interventions for parents to protect female children more effectively. For my second research question, I decided to investigate what is the predicted number of missing children's reports in California for 2024 and 2025, and I decided to use linear and quadratic regression models. So once again, I used data from the state of California's Department of Justice, and as you can see here, it's just the year, which ranges from 1996 to 2023, and the total number of missing children's reports for that year. So first, I came up with a linear regression model, and as you can see in the graph here, all the points are given, and so is the line, the least squared regression line. And the equation for this line is y cap equals 3,755,163.36 minus 1,821.416256x, where y cap is equal to the predicted number of missing children's cases in California, and x is equal to year. For the linear regression model, I got r squared is equal to approximately 0.62594, which would indicate that approximately 62.59% of variability in number of reports for missing children in California can be explained by its linear relationship with years. Next, for the correlation coefficient, I got R is equal to negative 0.79116, which indicates a strong negative linear relationship between years and number of reports for missing children in California. Next, for our predictions, I just plugged in the years into the equation. And as you can see here, I plugged in 2024. And the linear model predicts that in 2024, there will be approximately 68,617 reports of missing children in California. Next, I plugged in 2025 to the equation, and the linear model predicts that in 2025, there will be approximately 66,795 reports of missing children in California. Next, I did a quadratic regression model, and as you can see here, this is the equation for the line, and the graph below shows what it looks like. And for the quadratic regression model, I got a R squared of 0.745, which indicates that approximately 74.5% of variability in numbers of reports for missing children in California can be explained by its quadratic relationship with years. And the R squared value for the quadratic model is greater than the R squared value for the linear model, which indicates that the quadratic model more closely matches observed data and is more accurate at predicting future outcomes. Once again, I plugged in the years for the predictions, and the quadratic model predicts that in 2024 there will be approximately 52,652 reports of missing children in California. And when I plugged in 2025, it predicted that there will be approximately 47,528 reports of missing children in California. So comparing the results between the linear regression model and the quadratic regression model. Well, the predictions for the linear regression model exceeded that of the predictions of the quadratic regression model. The R-squared value of 0.745 for the quadratic regression model exceeded that of the linear regression model. This may indicate that the quadratic regression model makes more reliable predictions. So while I was running the regressions for the linear and quadratic, I also came up with this regression model, which is a polynomial regression model with a polynomial degree of 6. And the equation is shown here, and the graph is shown here. And as you can see, the line actually fits the points a lot better. And it actually had an R-squared value of 0.853, which indicates that it makes more reliable predictions compared to other graphs. However, I wasn't able to use it because we haven't learned about such complicated models yet. So, how does data analysis affect missing children in California? Firstly, it can be used to predict future trends of missing children's reports in California. Secondly, it can be used to raise awareness on the issue of missing children. And lastly, I'd like to highlight some steps that parents can take in regards to this issue. Well, firstly, they can educate their children about safety. Secondly, they can set boundaries. And third, they can keep in touch with the technology. So some reflections on my project. Firstly, what went well? Well, I had reliable and representative data source. I had a statistically significant p-value in my two-sample t-test, and I had a high R-squared value for the quadratic regression model. However, some things went wrong. For my two-sample t-test, I only had 28 years for my data, which is less than 30, so I couldn't assume normality. So I have to be cautious with my findings. Additionally, neither of the regression models had an R-squared value that exceeded 0.8, so they may have some limitations. So for next steps, well, first I could wait for more data to be released by the California Department of Justice so that n is equal to 30 for assumption of normality to be achieved. Additionally, I could use the polynomial regression model with a polynomial degree of 6 for the regression predictions, as it seems to be more reliable. And here's my works cited page. Thank you so much for listening to my presentation.